Okay, so welcome to all of you. Now today we will see the revision of the successive differentiation. You know that successive differentiation means what? Y. If y is the function, then y1 is the first derivative, y2 is the second derivative, y3 is the third derivative, dot dot dot, yn is nth derivative of y. Okay, so we are familiar. So if you want to find the detailed solutions of this one, so there is a lectures on successive differentiation formula and examples. Okay, so you can see that lectures for details. Okay, so just here we are revising the formulas only, and we'll see some small applications of the formula. Okay, so suppose if y is equal to x plus b raised to m, okay, then yn nth derivative is a to the power m minus 1 m minus n plus 1. This is okay. So this should note this. This is what x plus b to the power m minus n. So here what this condition is very important here. M is greater than n. That means still you can take a derivative of this one. Okay, because your m is greater than n, strictly greater than n. Okay, so that means this is in the factorial notation. This is in the factorial notation in this m factorial upon m minus n factorial a raised to n ax plus b raised to m minus n, m greater than n. Okay, so these both are the same, but this is not a factorial notation. This is in terms of factorial notation. Now this is what n factorial or m factorial, doesn't matter for this, a raised to m, a raised to n, because your m is equal to n. So we are finding n, so therefore we are using n. Okay, so n factorial a raised to n. Okay, and if m is less than n, then this derivative is 0. So you know that if a polynomial of degree 2, then the third derivative, second derivative is constant, third derivative is 0, fourth derivative is 0. So your m is what? Less than n. You are taking the higher derivative, right? Your polynomial is less than the this n. So that means the derivative is 0. This is 0. Okay. Now what is the application of this one? Suppose suppose you are given y is equal to twice x plus 3 to the power m, suppose to the power m. Okay, and they want yn. Okay, so where m is equal to n now, m is equal to n, then this is what? 2 raised to n. This is what? 2 raised to n into n factorial. This is the value. This is the value. Okay, so remember that. Now if y is equal to x raised to m, okay, then yn is equal to 0 if m is less than n, because derivative is 0. So your m must be the less than n. Okay, and this is equal to n factorial if m is equal to n, or you can write here m factorial also, doesn't matter this. But what you are taking nth derivative, so therefore I write it n factorial, because this is what x to the power n there. Okay, so that means what? If y is equal to x to the power n, then we will write no need to write relation that m is less than something like this. Okay, so this is what? This is the n factorial, and yn plus 1. See, this is degree n. Your nth derivative is constant, so this is n factorial, and all the derivatives higher than n are 0. So this is 0. So yn plus 2 is 0, and so on. Okay. Now this is the example here. So y is equal to 3x plus a, y is 0 if m is less than n. Okay. And if m is equal to n, then this y is what? Then 3 raised to n factorial if your m is equal to n. Okay. So this is the example. Okay. Now suppose this y is equal to log of x plus b. So then y is what? You should remember the formula. Okay. So y is equal to minus 1 raised to n minus 1 factorial a raised to n x plus b. So if you want y minus 1, that means n minus 1 third derivative of this one, just replace n by minus 1. So this is what is minus 1 n minus 1 n minus 2 factorial a raised to n minus 1 upon ax plus b raised to n minus 2 now. So n minus 1. You have to replace n by n minus 1. Suppose you want y n minus 2. n minus 2 the derivative of this one. Just replace n by n minus 2 now. So n minus 2. This is what? N minus 2 minus 1, that means n minus 3. A raised to n minus 2 upon ax plus b raised to yn minus 2. That means what? N minus 2. Whatever this is here. Okay, y in here. Okay, remember this. In this way you can find. Suppose you want to have y 100 then. Suppose you want y 100 suppose. That means you want 100 the derivative of this one. So this is your formula. Your y is equal to log of ax plus b. This is your formula. So 100. Just replace this is what? Minus 1 raised to 100. 99 factorial. A raised to 100 upon ax plus b raised to 100. Okay. So minus will not be there because minus 1 to the power even power is always 1. So this will not there. So in our option there may be the 99 factorial a raised to 100 upon something like this. Okay. So value may be given. This is what? Suppose log of twice x plus 3 suppose. Just your a is what? You have to take the care of a only here. This is what? A is 2. Coefficient of x. You have to take. So that means what here? N minus 1. I write yn minus 1 for this one. So I have the formula for this one. Okay. So minus 1 raised to n minus 1 because I am finding n minus 1 derivative. This is the nth derivative. Then this is what? N minus 2 factorial 2 raised to n minus 1. A raised to n minus 1. Right? Upon whatever this is the power. Whatever this is what? Twice x plus 3 raised to n minus 1. Okay. So this is your y is equal to, if y is equal to log of twice x plus 3, then y minus 1 is equal to this. You can write y minus 2, you can write y 100, y 101, 1001, something like this. Just replace here n by your figure. Okay. So take the care of this one. This is the formula for n. Okay. Okay. So this is the application of this formula. I told you that. Okay. So if y is equal to a raised to mx, then n is equal to, see, if y is equal to a raised to mx, then what is y1? y1 is m, a raised to mx. Right? What is y? Log a into log a. Okay. Now m log a is constant. M log a is constant. So I did what? M log a is constant. Right? So a derivative of a raised to x. Again this. Right? M log a into a raised to mx. Right? So that means what? This is what? M square log a square a raised to mx. Now same thing here. What? M raised to n, a raised to mx as it is. Log of a to the power m. Okay. So they will ask you what is the something like this. If y is equal to 3 raised to suppose mx now, or 3 raised to nx now. Suppose this is nx. Okay. So then yn is equal to what? M raised to n. That means n raised to n. N raised to n. Whatever this number, you have to take the power of this. Okay. Power of this. Okay. A raised to mx. So 3 raised to nx as it is. So log of 3. Well, derivative is what? Nth derivative. This n. This is what? This is what? N. This is n. Log a raised to n. M raised to n. Log a raised to n. Okay. So this is the formula. You should remember this. Okay. Now same thing here. We write this formula. Okay. So y is equal to e raised to x. Then yn is equal to what? A raised to n, e raised to ax. So similarly what? Y is equal to e raised to ax plus b. Then yn is equal to a raised to n, e raised to ax plus b. Ax plus b is there. Okay. Noted. We can simplify this. This is what? A raised to n, e raised to b will be as it is now. Something like this also. E raised to b into. Because what? The rule of the indices. You can take if the base are same and the product is there, you can take the sum of the indices, right? So b into b plus ax, that is ax plus b like this. Okay. So this is the application of this one. Now suppose y is equal to 1 upon ax plus b. Y is equal to ax plus b. Then what is y? A raised to n. Okay, minus first we write, right? So first we write minus 1 raised to n, a raised to n, n factorial should be there. N factorial, a raised to n upon ax plus b raised to n plus 1. For log there is n only, but for 1 upon x plus b there is n plus 1. So y minus 1, what? Minus 1 to the power n minus 1. n minus 1 factorial a raised to n minus 1 upon ax plus b raised to n minus 1. Okay, n minus 1. Yn minus 2 is what? Minus 1 raised to n minus 2, n minus 2 factorial a raised to n minus 2 upon ax plus b raised to n minus 2 plus 1, so n minus 1. Or yn plus 1, yn plus 1 also you can find. This is what? Minus 1 raised to n plus 1, n plus 1 factorial a raised to n plus 1 upon ax plus b raised to n plus 2. If y plus 1, if y 100 you want 100, this is what? Minus 1 raised to 100, minus 1 raised to 100, 100 factorial a is a raised to 100 upon ax plus b raised to 101. Okay, so this will not be there in the option. So because minus 1 to the power 100 is a positive, so this may not be there. Minus 1 raised to 100 may not be there. Okay, so you should suppose this is not there. Okay, that means what? This is also correct. 100 factorial, because what? Minus 1 raised to 100 is a positive, so therefore it is not in the option. So don't worry about that. Suppose y is equal to 1 upon 3x minus 4. 3x minus 4. Then what is yn? Yn is equal to just this is what? Minus 1 raised to n, 3 raised to n factorial. So you can, this is what order is important here. You can write here minus 1 raised to n factorial into 3, it doesn't matter this. Okay, so this is 3x minus 4 raised to n plus 1. Okay, if your y is equal to 1 upon 2 minus 3x, suppose 2 minus 3x, then yn is equal to minus 1 raised to n factorial minus 3 raised to n, minus 3 raised to n upon 2 minus 3x to the power n minus n plus 1. Okay, so this is minus 1 minus 3, so this is minus 1 raised to n. This I can write this as what? See minus 1 raised to n factorial, this is minus raised to n 3 raised to n upon 2 minus 3x to the power n plus 1. Okay, so this is minus 1, right? So this is minus 1, base are same, so you have to take the sum of the indices, that is minus 1 to the power twice n. This become what? Minus 1 to the power twice n factorial 3 raised to n only. Okay, so 2 minus 3x raised to n plus 1, and this is always positive. Minus 1 to the power even power is always positive. So that means what? Here minus 2 to the power 1 is 2 to minus 1 to the power twice n will not be there in the option, and this is what? 3 to the power n is there. 3 to the power n is there here. Okay, n factorial. Although even 3 is what? Negative here. Okay, but here we have given only the 3 factorial, so you have to take the care of that also. Okay, so that means what? That means what? We make a formula 1 upon a minus, okay, b minus ax will write here. Okay, b minus ax. Then your y is what? No need to write that minus 1 raised to n. Directly you will write what? N factorial into a raised to n upon b minus ax to the power n plus 1. If y is equal to b minus x, then the nth derivative is this. Okay, you can make this as a formula also. This is your formula. If your coefficient is minus now here, okay, you can do this formula. This is the application. How to apply that formula while solving the problem. Okay, so this 1 upon we have taken. Okay, so the one thing is important, that y is equal to sine of ax plus b, suppose. Then your y is what? A raised to n sine of, okay, derivative of sine is sine only here. So ax plus b plus n pi by 2. This is very important. So if you want n minus 1, this is n minus 1 pi by 2. This is a raised to n minus 1. If you want 100 derivative, y100 is equal to a raised to 100 x plus b to the power 100 pi by 2 means 50 pi. Okay. Similarly, the formula is same for cos of ax plus b. Here what? Suppose y is equal to sine of twice x plus 3 or twice x minus 3, something like this. Okay. So then y is equal to what? 2 raised to n sine of, you have to write the angle as it is. Sine n, okay, everything is as it is. So this is what? N pi by 2. Only you have to add n pi by 2 in the angle of the sine. Okay, and just you have to write this 2 raised to n, coefficient of x. Okay, so if y is equal to sine of 3 minus 4x, suppose, then y is equal to what? Minus 4 raised to n. Okay, sine of 3 minus 4x plus n pi by 2. Don't do anything. Keep your angle as it is. Whatever this the coefficient of x is negative, positive, whatever this angle will be as it is. Just you have to add n pi by 2 in the angle. Okay. So don't do anything and just write here what the coefficient of x along with the sign you have to take. So coefficient of x along with the sign is -4. Okay. So you have to take the along with the sign. You have to take the care of this. If there is a cos, doesn't matter for this is cos. So this will be cos then. This will be cos. Then this will be the cos. Just formula for sin and cos both are the same now here. Okay. Okay. So that means if cos of x plus b, then yn is equal to what? A raised to n. Just I am writing here. I have already taken the example. Okay. So ax plus b plus n pi by 2. In cos also you have to do the same. The formula for sin and cos both are the same here. Okay. Okay. So now you have to remember this formula. Okay. So y is equal to e raised to x sin of bx plus c. Then y is equal to, sometimes they will call this as r. A square plus b square is r. Okay. So sometimes this will be given to you. This is what r raised to n by 2. R raised to n by 2 sin of bx plus c plus n theta, suppose. This is n theta. N theta. Okay. So that means you are putting that x is equal to r. A is equal to r cos theta and b is equal to r sin theta. Okay. So your a is what? In the power coefficient of x in the power of b, and b is what? In the angle, the coefficient of x in the angle of the sine. That is your b now. Okay. So you know that this is what? So b upon a. What is b? R sin theta. What is a? Cos theta. You are gets cancelled. Sin theta upon cos theta is what? Tan theta. So theta is equal to what? Tan inverse of b upon a. Right? And what is r then? R is what? Just you have to take the square. What is a square plus b square? A square plus b square is what? R square cos square theta plus r square sin square theta. So if you take the r square common, we get cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. Okay. So then this will be what? Only simply r. And r is what then? A square plus b square to the power r by 2. Okay. So this is r. This is 1/2. Okay. By 2. A square plus b square to the power. And this is what here you have to write r raised to n. R raised to n is nothing but what here? N by 2. So you have to write this n by 2. Okay. So this formula is there. So actually this should be r raised to n. Okay. This should be r raised to n, not r raised to n. Okay. So value of r is this. So this is what? A square plus b square to the power n by 2 sin of bx plus c plus n tan inverse of b by a. Remember this formula. Same thing formula for cos also. Okay. Now suppose you want to find nth derivative of y e raised to twice x sin of 4x, suppose. Okay. So what is y then? Yn. So a square plus b square. This is your a. This is your b. Okay. Just say only the a square plus b square. So a square is what? 4 plus b square is what? 16. Okay. Raised to n by 2. Raised to n by 2. So angle this e raised to twice x sin as it is now. Sin x. Angle is also as it is. Plus n. Tan inverse of. What is your b? B is 4 upon 2. N tan inverse b by a. Just you see it. This is what then? This is what? 20 n raised to n by 2. E raised to twice x sin of 4x plus n tan inverse of 2. We don't know the value of tan inverse of 2. We are keeping this as it is. So this will be your correct option. Suppose y is equal to e raised to x cos x, suppose. Cos x or sin x, doesn't matter for cos x or sin x. Answer will be the same. Only sin as cos, okay? Or cos as sin only, okay? So then your yn is what? A square plus b square. Your a is 1, b is 1. A square plus b square is 1, is 2. So this is what? 2 raised to n by 2. Okay? So cos of x plus n tan inverse of 1 then. Okay? And tan inverse of 1 is pi by 4. So this may be the pi by 4. N pi by 4. Your answer will be what? N pi by 4. So that means what here? This is 2 raised to n by 2 cos of x plus n pi by 4. This will be the answer. If there is a sign, if suppose there is sin x, just you have to replace sin. So this will be the sign only. This is the difference. Okay. So this is the application of this formula. Okay. So these are the formulae. These are very important here. Okay. After that, so Suppose y is equal to a cos log x plus b sin log x. Okay, so maybe a and b are maybe interchanged like this. Okay, so what is y1 then? You should remember y1. What is y1? So this a is constant. Okay, so a will be as it is. Derivative of cos is minus sign log x into derivative of log x, that is 1 upon x, plus what is this? This is what b as it is. Okay, the derivative of sin is cos log x into 1 upon x. You can shift this x to this side, so y1 is equal to what? Minus a sin of log x plus b cos of log x. Again I will differentiate this, but if you differentiate this, this is what then x, derivative of y1 is y2 plus y1 plus y1. Again I will differentiate this. This is what then minus a cos of log of x into 1 upon x minus, this is minus b sin of log x upon 1 by x. Just again I will shift this x. So this is what? X square y2 plus x y1. Okay. So then this is x is not there, this is x not there. So if you multiply by minus here, so we get what? Minus y. That means what? This is x square y2 plus x y1 minus y is equal to 0. That means your y is equal to this. Then this is x square y2 plus x y1 minus y. This will be your this is your here. Okay. So our this is what here. This will be what? Your minus. Okay. So if both are a there, then this directly you can write this is minus a minus y directly. If a and b are the same, then this will be what here? Minus y then. Okay. Remember this. Okay. So next you have seen Leibnitz theorem. So if y is equal to uv, so that means if you want to find the nth derivative of the product, then we are using Leibniz theorem. Okay. So to differentiate your product, n time differentiate you want, so then this is what Leibniz theorem is useful for that. Okay. So then this is denoted by, okay, I write here yn is equal to uvn. Okay, so n is a positive integer. That means n is a natural number. N is natural number means it is a positive integer. Okay, so I can write this is what? nc0. If nc0 is not there, doesn't matter. This is what? unv of 0. That means what? Just you can write simply v instead of this. This 0 means 0th derivative of v. So you may write this is what? Okay, so okay. Plus nc1 u n minus 1 v1. Okay, plus nc2 u n minus 2 v2 plus, you should remember this, nc plus dot ncr u n minus r vr plus dot plus ncn u 0 u derivative of u, that is u, simply u can write this is what? vn. Okay, so you may write this is what? u0 is simply u, v0 is simply v, okay. So this is the Leibniz theorem to find the nth derivative of the product. Okay, now suppose our y is x cos x or x sin x, whatever this. This is the product and we want to differentiate this n times. So now see, this derivative of x is what? First derivative will be 1, second derivative will be 0, right? So that means what here, how we can apply the yn then? Yn is equal to what? nc0. I will call this cos x, I will take u as a cos x, and v what? Whose derivative vanish, that I will put as v now. Okay, so your x as it is. Okay, this is 0 as it is. plus nc1 cos x n minus 1 derivative and derivative of first derivative of x. Now see in the second term, your second derivative, this is what second derivative of x now, but the second derivative of x is 0. So after that all the terms are 0, because what, second derivative of x is 0, third derivative of x is 0, because this is the polynomial, a polynomial will be 1, only the first derivative constant, all the derivative here 2 or more than 2 will be the 0. Okay, so no terms are there. Okay, so nc0 is always 1, nc0 is always 1. So nth derivative of cos x, nth derivative of cos x is what, cos of x plus n pi by 2. A raised to n is there, but 1 raised to n we are not writing 1 raised to n. Okay, and 0th derivative of this way x will be x as it is. nc1 is n. Okay, so 1 raised to n, this is what, cos of x plus n minus 1 pi by 2, because you are taking n minus 1 derivative, and first derivative of x is 1. Okay, so this is your answer, x cos x plus n pi by 2 plus n cos of x plus n minus 1 pi by 2. This is your correct solution for x. Similarly, for if sine is there, no problem for this is what, just sine will be there, just sine will be here. This is what, this is sine, this is only the sine, this is sine, this is sine. Okay, for you x, sine x or cos x, answer is same here, only what, sine will be replaced as cos only, all others are same. So this is the use of the Leibniz theorem. Okay, suppose if y is equal to, if y is equal to x, y, okay, instead of this, suppose you have x square y, y2 suppose, and we want to find the nth derivative of this one, y2 means the second derivative. Okay, so this is what then, so actually this is not, okay, so x square, second derivative is constant, third derivative 0, that means I have to write a Leibniz theorem up to nc2. Okay, so nc0 y2 nth derivative x square as it is, okay, plus nc1 y2 n minus 1 derivative of y2, this is x square. Okay, so a first derivative of x square, okay, plus nc2 y2 n minus 2 and second derivative of x square. Okay, so second derivative of x square is constant. Okay, so third derivative of x square is 0. So I am now writing the further term. So this is what then, nc0 is 1. So this is what, x square yn plus 2, yn plus 2 plus nc1 is n. Okay, so then this is the derivative of x square is twice x. So this is what, twice nx. Okay, twice nx. Okay, and this is what, y, you have to take the sum of this one, yn plus 1, yn plus 1 plus nc2 is what, n into n minus 1 upon 2 factorial. Okay, so yn, and second derivative of this, first derivative of x square is twice x, again you have to take the difference, this is 2 then, this is 2. Okay, and if you simplify this is what, x square n plus 2 plus twice nx yn plus 1, this 2 get cancelled. Okay, plus n into n minus 1 y. Okay, so within a minute you can find this one. Okay, so if you have practice, within a minute you can judge this. Okay, so options are already provided to you. Okay, so you have to judge only this, the coefficient of yn plus 2, coefficient of yn plus 1, yn this. Okay, so if you have the practice you can do this. Suppose f of x plus h is equal to cos of x plus h, and you want f double prime of x now. You want f double prime of x. So f of x plus h, that means what here? F of x is cos x. F of x is cos x. That means what? F prime x is equal to minus sin x. F double prime x is equal to minus cos x. Right? So if f of x plus h is equal to e raised to x plus h, then your f of x is what? E raised to x. And you know that any derivative of this is what? So that means what? Your third derivative of x is 1. That is e raised to x. Any derivative of e raised to x is e raised to x. Okay, so this is the see. Suppose y is equal to e raised to sin inverse x. Y is equal to e square. So what is y1? Y1 is equal to e raised to sin inverse x into derivative of sin inverse x 1 upon root of 1 minus x square. So that means what here? Y1 is equal to y upon root of 1 minus x square. That is what? 1 minus x square y1 square is equal to y square. This is the relation. Y is equal to e raised to sin x up to this. Okay, this will give this relation. Okay. Now suppose y is equal to sine of m sin inverse x. M sin inverse x. Okay. So now we find y1 then. We'll find y1. So y1 is equal to what? So cos of m sin inverse x into derivative of m sin inverse x. That is what? M upon root of 1 minus x square. Okay. So now this is cos. Cos means what? 1 upon root of sin square. That means y1 is equal to what? Root of 1 minus y square. Okay. Into m upon root of 1 minus x square. And if you take the square and if you shift this here, so what we get? 1 minus x square. Y1 square is equal to m square 1 minus y square. Okay. So this is the relation. Just type of this relation you should know. Okay. So for this, and then you can apply again. You can apply the second derivative. You can find y2, and then you can jump to the this. For that, you have to find this. Okay. Now suppose you have this 1 minus x square y2, and you want to find the nth derivative of this one. 1 minus x square y2. How we can write this? This is what? nc0 n. Okay, and 1 minus x square as it is. Okay, 0th derivative plus nc1 y2 n minus 1 1 minus x square 1 minus x first derivative plus nc2 y2 n minus 2 n minus 2 1 minus x square second derivative. Third derivative is 0, so we are not writing that. nc0 is always 1, so this is what? 1 minus x square yn plus 2 plus nc1 is n y, this is y n plus 1, and this is what? Minus twice x. Okay, plus nc2 means what? n into n minus 1 upon 2 factorial yn, and derivative of 1 minus twice x, so derivative of minus twice x just we have to take. This is minus 2. Okay, now this is what? Then 1 minus x square yn plus 2 minus twice nx yn plus 1, the 2 get cancelled, minus n into n minus 1 yn. Okay, so this is very easily you can find the nth derivative by using the Leibnitz theorem. So when we are using the Leibnitz theorem, if you want to find the nth derivative of the product, we are finding it. What is n? N is the positive integer. That means it is a natural number. Positive integer means it is a natural number. So this thing you should remember this. Okay. Now if you want to find x square y1, suppose x square y1. Okay, suppose you have x square y1 and you want to find the nth derivative of this one by Leibniz theorem. So this will what? Then nc0 y1 n x square plus nc0 y1 n minus 1 x square first derivative plus nc1 y1 nc2 n minus 2 nc1, this is nc1. Okay, nc1 x square second derivative. You have to stop this. Okay, so what is it then? X square. Okay, yn plus 1. Just check where is x square yn plus 1. If there is only one option which contains x square yn plus 1, then that will be your correct option. Okay, no need to find this term. Okay, so plus. Suppose the x square yn plus 1 is contained in everywhere. Okay, then we will find only just simplify the second term. If your first two terms, that means this is what? Y. So if yn plus 1 and yn, these terms are the same, then don't simplify this. Only simplify this term then. Okay. So look at the option. Okay. Okay. So that is nc1 is n. This is what? Then derivative of this is what? Twice x. So twice nx. Derivative of this one. Okay. So yn then. So nc2 means what? N minus 1 upon 2 factorial into yn minus 1, yn minus 1. Derivative of second derivative of this is 2. Okay, second derivative is 2. So these two get cancelled and just take this. Okay, so this will be the answer. In this way you can solve the problems by using the Leibniz theorem. So simple problems you have to solve by using the Leibniz theorem. You don't have to do the complicated problems here. Okay, complicated means what? You don't have to do all the full solution of this one. What? Just you have to think that 1 plus x square is y plus 2, something like this. Such type of the expression we have seen. So that will be not for the competitive. They will not ask for the competitive exam because they are competitive. Within a minute you should solve such type of the problems will be there. Okay. Okay. So I hope that you understand all those things. Okay. So Leibniz theorem, Taylor theorem. So you should remember the Taylor series expansion of all the functions. So what? So I have not taken Taylor series expansion in the previous lecture. So you should remember that e raised to the sin x, e raised to tan inverse x, expansion of e raised to tan x, something like this. Okay. So you should also remember that. Okay. I hope that you understand how to find the nth derivative of any terms here, any function. So how to apply the Leibniz rule for the product of the function, that we have seen. Okay. So just you have to solve your own now. Okay. Okay, so x square y1 is there. So you take x cube y1, you take x square y2, you take x square y3, something like this. Okay, and find their nth derivative. Okay, so I hope that you understand all those things. Okay, so we'll stop here. Thank you.